Good afternoon everyone, thanks for joining me again. In this video I'm going to do the first few questions of this particular past paper. It is the AQA higher tier paper 1, the non-calculator paper, and this particular paper was from November 2017. This paper is freely available from the AQA website, which I will link in the description down below. I recommend, before you continue with this video, that you take a look at the paper and have a go at the questions. So do that now, and we can make a start. So, first question, a SERDS question. Work out 2 to the power of 6 plus 6 to the power of 2. Okay, well, of course, if this was a calculator paper, you could always use your calculator, but since it's a non-calculator paper, we need to be able to work this out. So, what does all of this mean? Well, 2 to the power of 6 is the same as 2 times 2 times 2 times 2 times 2 times 2. So that's 6 2's, 2 times itself 6 times. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So 2 to the power 6 is 64. 6 squared, well, that's simply 6 times 6, which is 36. Now we have to add these up, because it's 2 to the power 6 plus 6 to the power 2. Add these up, 36 plus 64, and then we square root that. So that's the square root of 100, which is 10. So our correct answer there is 10. Okay, what is 800 million in standard form? Okay, there are 2 ways that you can attempt this. You can write out 800 million, so 800 million, and then you can see how many times you move the decimal place, and then write it out as 8.0 times 10 to some power. Or another way you can do it is to just start off here with what they say, 800, and then if you know that a million is times 10 to the 6, so here when we're not quite in standard form, as you see here, they've even given you this solution here, maybe in the hopes of tricking some candidates to go for the wrong answer. So we need to make this so that it's just 8 times 10 to the power of something. So just ignore the times 10 to the 6 for a second. 800 will be 8 times 10 squared, 8 times 100, because you move the decimal place twice. And then we've also got the times 10 to the 6. Combine those, you'll get 8 times 10 to the 8, because we add the powers. So that there is our solution. And here, if you would have done the same thing, if you would have counted here, you would have found out that that was 8 as well. Circle the expression that is equivalent to 4a to the power of 5 all squared. Okay, so what does this mean? This means that we have 4a to the power of 5 multiplied by 4a to the power of 5. So here, another way of writing this out could literally just be to say that it's 4 times a to the power of 5 times 4 times a to the power of 5. Now, if you have 1 times 2 times 3 times 4, it doesn't matter the order that you times those numbers, you will always get 24. So if you decide to do 3 times 2, which is 6, then times it by 1, which is still 6, times it by 4, you get 24. So the order here that you times these doesn't matter. So the numbers, you can do 4 times 4 first, which is 16, and then do the a to the power of 5 times a to the power of 5, so we add the powers and we get a to the power of 10. 16a to the power of 10. So that there is our first 3 marks. Next lot of questions. Question 4 now. Y equals 10 over 5 if the value of x doubles, what happens to the value of y? Okay, let's attempt this one by actually putting in some numbers. So I'm going to say that if x equals 1, so if we put x equals 1 in there, y would be 10. That's quite an easy one. 10 divided by 1 is 10. Well, here it's talking about the value of x doubling, so let's double our value of x and see that x is equal to 2. What would the value of y be then? So that would be 10 divided by 2, which is 5. So what here has happened to our value of y? Well, we've went from 10 to 5, so we've divided it by 2. So that there is the answer. The next example, the next question, factorise x squared minus 100. This kind of factorisation is something that trips up candidates all the time. It's something that you need to be familiar with. Okay, this is a difference of two squares, or sometimes referred to as dots. So this here is where you have x squared minus a squared. So you have two squares and you're subtracting them, so you literally have the difference between two squares. So in this case here, the x squared is just the x squared, but here the a squared is 100. So a would be 10, because the square root of 100 is 10. So the way you write this is you say that this here would be x minus a, x plus a. Sorry, the way you factorise that, sorry, not the way you write it, the way you factorise this. We say it's that. So a is 10, so it's simply x minus 10, x plus 10. Oops, x plus 10. And that there is the answer. X minus 10, x plus 10. As you can see, I just do all of my videos in one take. Okay, next one, an inequality. I've had a few people message me about inequalities, so I am going to do a dedicated video on that. But the idea of me going through this paper isn't really to teach you about every single question, otherwise it would take me hours to go through this paper. And I'm sure that most viewers aren't going to sit there for 8 hours to watch me go through one paper. So to do this, you can kind of pretend that it has an equal sign instead. So let's work forward with this example first. So here we can subtract 2x off both sides, and we have 5x plus 6 equals 1. Subtract 6 from both sides. We have 1 subtract 6 is minus 5. And then we need to divide both sides there by 5. We get minus 1. X is minus 1. Okay. Well, you do the same steps here, but you leave the greater than sign the way it is. So you don't do anything with this. So we can subtract 2x off both sides to begin with, and we will have 5x plus 6 is greater than 1. Minus the 6 off both sides, and we'll have 5x is greater than minus 5, and then divide both sides by 5. X is greater than minus 1. And that there is our answer. X is greater than minus 1. So that's how we do that. Now, there is a complicated matter with inequalities when you need to divide both sides or times both sides by a negative number. But I'll go into that in the future when I actually do a dedicated video on inequalities. But there are the answers to the first 5 questions for this paper here. The AQA higher tier paper 1, the non-calculator paper, from November of 2017. So have a go at those 5 questions. I will upload the next few, I will film the next few questions in a moment. I'll try and split the whole paper up into roughly equal sized videos. Hopefully I can get them all to be about 10-15 minutes. And then, you can, if when you look at the paper you're only struggling on the very last question, then obviously once I've uploaded all of the clips for this paper, just look at the final video of this series, and you will find the help that you're after there. But in the meantime, I'd just like to let you all know that I've made a new subreddit so that I'm not spamming the GCSE and sixth form subreddits as much. The title of that I will leave down in the video description. The subreddit is called Mr. Watson YouTube, so feel free to go over there and put in any requests for any videos. I have also linked on the subreddit, I have also linked a Google Doc link so that you can see what videos I'm currently working on, what videos I've recorded, what videos I've shot, what videos I have planned to do next. I've not filled out the whole document yet. There's still quite a lot of stuff that's missing, but in the coming days, by the time most of you watch this, it will be relatively complete. So thank you very much for watching, and I will see you next time.